Today we discuss about the partial differential equation of first order. Definition: an equation involving partial derivatives is called a partial differential equation. The next definition: the order of the partial differential equation is the order of the highest partial derivative occurring in the equation. For example, the order of the partial differential equation dou squared y by dou x squared plus dou y by dou x is equal to 5 is 2. The degree of this partial differential equation is also 2. One more example, the order of the partial differential equation dou squared x by dou t squared plus dou x by dou t the whole cube which is equal to 3 is 2. Degree of this partial differential equation is 3. Remark: if x, y are independent variable and z is dependent on x and y, then we write p is equal to dou z by dou x and q is equal to dou z by dou y. In general, f of x, y, z, p, q equal to 0 represent a partial differential equation of first order. Method of finding the partial differential equation of the function f of x, y, z, a, b equal to 0. Equation number 1. Differentiating 1 partially with respect to x, we get dou f by dou x plus dou f by dou z into dou z by dou x is equal to 0. We know that p is equal to dou z by dou x. This implies dou f by dou x plus p into dou f by dou z equal to 0. Equation number 2. Differentiating 1 partially with respect to y, we get dou f by dou y plus dou f by dou z into dou z by dou y equal to 0. We know that q is equal to dou z by dou y. This implies dou f by dou y plus q into dou f by dou z equal to 0. Equation number 3. Eliminating a and b from equation number 1, 2 and 3, we get the partial differential equation of the form f of x, y, z, p, q equal to 0. Find the partial differential equation of the following by eliminating the constants c and a from the equation. For example, x square plus y square plus z minus c the whole square equal to a square. Equation number 1. Differentiating 1 partially with respect to x, we get 2x plus 2 into z minus c into dou z by dou x equal to 0. We know that p is equal to dou z by dou x. This implies x plus z minus c into p equal to 0. This implies z minus c is equal to minus x by p. Equation number 2. Differentiating 1 partially with respect to y, we get 2y plus 2z minus c into dou z by dou y equal to 0. We know that q is equal to dou z by dou y. This implies y plus z minus c into q is equal to 0. This implies z minus c is equal to minus y by q. Equation number 3. From 2 and 3, we get x by p is equal to y by q. This implies qx is equal to qx minus py equal to 0. This is the required partial differential equation. One more example, x squared plus y squared equal to z minus c the whole square tan squared alpha, where c and alpha are constant. Equation number 1. Differentiating 1 partially with respect to x, we get 2x is equal to 2 into z minus c into dou z by dou x tan squared alpha. This implies x is equal to p into z minus c tan squared alpha. This implies x by p is equal to z minus c tan squared alpha. Equation number 2. Differentiating 1 partially with respect to y, we get 2y is equal to 2 into z minus c dou z by dou y tan squared alpha. This implies y is equal to q into z minus c tan squared alpha. This implies y by q is equal to z minus c tan squared alpha. From 2 and 3, we get x by p is equal to y by q. This implies q is equal to yp is the required partial differential equation. Try to solve the problems x minus a the whole square plus y minus b the whole square plus z square equal to 1 and z is equal to x plus a into y plus b. Find the partial differential equation of the following by eliminating the functions from the equation. Example, z is equal to xy plus f of x squared plus y squared. Equation number 1. Differentiating 1 partially with respect to x, we get dou z by dou x equal to y plus f dash of x squared plus y squared into 2x. We know that p is equal to dou z by dou x. This implies p is equal to y plus f dash of x squared plus y squared into 2x. This implies f dash of x squared plus y squared into 2x is equal to p minus y. This implies f dash of x squared plus y squared equal to p minus y by 2x. Equation number 2. Differentiating 1 partially with respect to y, we get dou z by dou y is equal to x plus f dash of x squared plus y squared into 2y. Simplifying, we get the equation number 3. F dash of x squared plus y squared equal to q minus x divided by 2y. Solving 2 and 3, we get p minus y by 2x is equal to q minus x by 2y. This implies y into p minus y equal to x into q minus x is the required partial differential equation. One more example, z is equal to x plus y plus f of x, xy. Equation number 1. Differentiating 1 partially with respect to x, we get dou z by dou x is equal to 1 plus f dash of xy into y. We know that P is equal to dou z by dou x. This implies P is equal to 1 plus f dash of xy into y. This implies P minus 1 is equal to f dash of xy into y. This implies f dash of xy is equal to P minus 1 by y. Equation number 2. Differentiating 1 partially with respect to y, we get dou z by dou y is equal to 1 plus f dash of xy into y. Simplifying, we get equation number 3. F dash of xy is equal to q minus 1 by x. From equation 2 and 3, we get p minus 1 by y equal to q minus 1 by x. Simplifying, we get x into p minus 1 is equal to y into q minus 1 is the required partial differential equation. Try to solve the problems z is equal to f of x minus y and z is equal to f of xy divided by z. Thank you.